Hello. Okay. At last lecture, we had quite a bit hiccup because they blocked this Twitter blocked all those public API search. So I was not able to download the tweets, and and I hope that we can still do this assignment with scraping Twitter. I did have a lecture for the last cohort. I did have a lecture about web scraping also. Web scraping is just um, to like scrape down these HTML. So these are based on HTML, right? They, yeah, so it's based on the database. However, when you load on your page, it's a static HTML. So with some code, you can scraping down all these titles and dates, and then these what is these called variables or uh, like those were columns, table columns. So that's called web scraping. And, I will share the slide as well. But in this lesson, we are focusing on scraping text from Twitter. And I did find a workaround. This app is called Appify. It's not a free app. However, it does give you $5 when you try for the first time, and that $5 is sufficient for you to scrape something down for this assignment. Okay. For example, I try Elon Musk or I try Taylor Swift. I used Taylor Swift. Taylor Swift 13. That's his profile name. Okay, so Taylor Swift 13. I believe this is his profile. So if I search his profile, it will allow me to download his tweets. I think I tried 1,000, but actually I only downloaded 100 tweets. But it's okay. That's still 100 is still better than not able to download anything. Okay. So if I run this, see, it costs the money, but originally when I started, it will give me $5 free usage. So I'm still able to do this. So you download all the tweets she posted. These are all the pictures. I guess it look right. Okay, so yeah, we'll just use this data for our assignment. Okay, for that data scraping. John, then I mentioned we are talking about the Twitter scraping. So the code on my original slide, it doesn't work anymore because the Twitter blocked all these API search, and this is a workaround. You go to this website called AppFi, and then if you search some profile, like a Matthew's Twitter account, then you will download all the tweets you posted. It doesn't infringe any privacy, okay? These are public data you posted on their website, so it really doesn't infringe any privacy. So here let's see, okay, if I download it, how many tweets it downloaded. So it it downloaded okay, I see it did download like 200 only. So for this free account, it did only download like 101. So we'll just use this 101 entries for the analysis for the assignment. Okay. If you export it will give you if you give you a CSV file like this one, has a lot of data frame, a lot of columns, conversation ID. So that's the profile ID thing. Created like dates, and one of the column, this column D is the full text of the tweet post. Okay, this is a tweet. So we are going to analyze this tweets and to see, hey, what kind of things they're posting. So this this set of tweets is from Elon Musk. Yeah, they usually use this for lectures. Okay, so here I've downloaded this from this website, and what I need to do is to what I needed to do is just to so we can start from this slide. Okay, I added this instruction here. We're just going to read in this data frame and then do some easy analysis. For example, you can, so this data set has all the list, all the dates, right? You can see, hey, when does he like to post, at night or at daytime, kind of thing. Or on weekends, on weekdays, which days he likes to post. These are just basically exploratory analysis you can do. And also you can count the length of her probe, his post. Are those long? Like how many words are usually there with each tweet, with each tweet. And you can also find the top tweeted, retweeted post. I believe this data set also included that in some of the columns. Just retweet. See, this one is the retweet. None of them is retweeted. Oh no. Anyway, with this data frame, a lot of easy data, just like some data summary task you can work on, right? Next thing we want to do, I want to demonstrate is to see what kind, like what usually we add the at sign, the sign to quote somebody, right? To call out to somebody. And the next thing I want to do is to see who he's calling out for. Okay. So what we want to do is just simply so you all can help me to work on this, okay? What we need to do is just to read in this data set. And then I call this data frame. Okay, so what we can do first is to join all the sentences together. So it will be just a one string, and then you can use a regular expression to find all these strings that start with this at sign. Okay. Do you call this at or something else? At, right? That's fine. What do you call at? Yeah. So what we want to do is to first to combine all these strings. All right. Where did it go? Oh. Combine all these together, so it will be in one string, and then we can use a regular expression. We can do it very quick. So you all can help me to write out this code. Oh, if data frame is column full text. This is an empty string, and then it's called a join. This one actually. Join I. Let's see if it works.
I think the text lowercase too, or is it a capital T for text?
Okay. Yeah. List object has no attribute join. So we need to take out this list object. So list object, we probably need to add another loop. So now we take out each element from this list. And okay, okay. I see. I said list objects has no join. So actually, this join applies to a list, not the object in a list. I, well, I believe yes. So will be okay. Yeah, so it works. So this drawing method is actually put a list together, so it doesn't need a loop to go over each list and then put them together. Uh, it, it doesn't need to. It doesn't need to go over each object and then like what we use, how we use append. So this drawing is actually the argument should be a list, not the object, the list. So here, let's see if it looks correct. And all these tweets put together in one string. Then now we can use the regular expression to work on this, right? To call to find all the texts that start with at. So how are we going to work on this? Re dot find all here it should start with at and then it goes with A to Z. I'll just copy this. Okay, A to Z and so this string should start with at and then it comes with these letters, all numbers, all this sign, underscore, and this star sign. Let's see if it works. And this string, we are going to apply this regular expression. Try to see if it works. Okay, it did find two. One is AOC and another is AOC as well. Let's verify if it's correct, okay? Click on verify. Tells me there's only one AOC. Right? Tells me there's only one AOC. See, let's see what's wrong here.
Maybe AOC is listed twice in the same tweet.
Well,
Then maybe in the same tweet, that one tweet, that at AOC is there twice, so it only shows up once because it's in one cell. It won't duplicate it on Excel, but it will show it on here
that
because
could be possible. I wonder if I like joined this twice, maybe. It could be like I combined the string
that could also be the case, yeah.
twice. So it,
Could you check the tweet in the JSON list?
let's see. All the way here. Yeah, I feel yeah. I joined it. You see, so that's a problem here. What I should do is to I just name another variable and then to run this again. So there's something wrong in my code. I feel this sentence is this one probably repeated it twice. Anybody find it the problem here? This doesn't look repeated, although. Huh?
Scroll like down a little bit. Thought I saw something.
What did you say?
You see how it says yes with the exclamation points? I've seen that repeated. I don't know if he just says yes a lot or the same amount of exclamation point.
See, is this one repeated on only the next one? This one looks 100 entries. This one is repeated.
Sure, Peter.
Yeah, so this data frame is repeated here.
Maybe it's repeated in the Excel file you're in.
No, it's not. In the Excel file, I didn't use this UN. Probably using another data frame I created earlier. So this should be live now. Oh, what's going on?
Got another theory.
Huh?
Where you make that sentence right there. Maybe change that to sentences equals brackets.
What do you say?
Right there, change that to sentences.
Oh, yeah.
Oh, okay. Yes. So that should solve the problem. Okay. Oh, it's correct now. Thank you. Next thing, actually this code here, I put it here is to count, like how many, if this person call out someone multiple times, then it will count. It will count the frequency of these words. Okay, he probably called in twice or mentioned once, and then this code will show how many times he called out each one. Okay, and the next thing we want to do is in the assignment, we want to find all the HTML. Oh, no, and all the URL links, yeah. How could we do that? So we want to change this one to HTTPS. See, we want to find all these HTTPS URL links and to see what kind of website he cite the most. So what we can do here is probably just like this, and then start with A, B, C, D. And it could have a slash and it could have dot, right? So instead of this underscore, it could have a dot, it could have a slash. Do I need to have this path? Or this be correct?
Wouldn't you need the colon?
Well,
Wouldn't you need the colon in there?
colon?
HTTPS.
Oh, okay, yes. Yes, sure, I need that. Let's see if it returns that. Okay, it did work fine. Looks correct, right? And then as you see, these are actually all the short links. A lot of the websites, they only use short links. So if you want to change it to it's full link, because we want to analyze which website the cite most. So if you want to change them to the full link, you have to add this code. Add this code. Find. Okay. Add this code to change all these links. to the four links. I'm not going to repeat here actually. I also not familiar with this code. I just look up and find it. So this change this each short link into a four link list. Okay, let's wait for it. All right. Next thing want to do. We already briefly mentioned the tokenization. We can put the string, disassemble the string into words, and then clean the words by removing punctuations, removing stop words, and then removing the stemming. And lemmatization is another option for removing the stemming. And then the next thing we can do is so we can see like what kind of words this person uses the most frequently. So the function used is frequent disk. This will return you a dictionary that is each word and its frequency here. Okay. Can quickly show that. So yeah, help me to remember how to do this. What we need to do is to just first one is tokenization, word tokenization, right? And then use this. We can just copy out this code, okay? So I want to apply this data cleaning to this my string. I'll go back to do it very quick. Usually after each step, I print out the result to verify. Sometimes the code looks all correct, but there will maybe something go wrong. So usually I print out the result at each step, okay? And then the next step is removing the punctuations. And then we do the stop words. It's much cleaner. Stemming. think we are done with the basic cleaning. So what I can do is to show the frequency of these words. Okay, so this frequent distribution, this stands for distribution, okay? That returns a dictionary with the distribution of each word that it counted. CHTTP, Twitter, and he often said let's do that something free. These are the most frequent words used in his post. And then of course, you can put it into a data frame, and then use this data frame to generate a nice frequency plot from the top frequent words into the low frequent words. Okay, that's what we. Okay. I don't want to go over this. Okay, I think you all are very familiar with this already. Next thing I want to mention is called name entity recognition. So basically, it could recognize the person's names, or some organization names from the text. Okay, and these when there are different types. Person, organization, or location can all recognize. Of course, it's not 100% accurate. You have to test to see, to get familiar with it. So what we need to do is to load this library called the Inco Web SM, and let's try. And this one is just create an object of this function. Okay. So we have loaded this library, and we can apply this function onto this sample text. Okay, let's see if it works fine or not. Oh, function. Oh, did it report an error or not? So it did report an error. Okay, install this one also. Wonder if this library has also changed recently. Did it install this? I'll try this one. Okay, looks like it works fine. Spacey.load. Oh, I don't think it worked anything on this text, fortunately. It just repeated it. Hmm? Um, okay, so returned an object with the attributes. So if we actually it's still the same. This object contains the string and it also contains these entity information. So we need to get the attribute from this result actually. So let's see. Okay, so looks works fine. See, this is the string we used, and then after apply this entity R, it created an object result, and this result it has all the entity information. So if you cite ENTS, believe this means to get the organization. It returns all those entity information. It has the organization and it has the GPE. GPE sounds like a country name or location. So it will recognize all the entity. Let me see if I type in then if it recognizes as a name, okay? Okay, it did work fine. So as you see, you can recognize a lot of those entity information in this text. There anything else we want to try if it returns the desirable result?
Twitter,
Twitter, should recognize it as an organization or something. Okay. This is O or A? It's A, right? Oh, didn't recognize anything. Yes, unfortunately, it didn't. So does that mean like this period doesn't matter? It should not, right? Oh, at least the comma will be good. Department of Space yeah, I didn't recognize Department of Space. It works fine. So as you see, it gives you each algorithm. It's not perfect. It does give you some useful information that you want. Okay, so this is the part for entity recognition, and then you can just yeah put into data frame and to count how many organizations are there in this text kind of thing. If we apply this thing to the string we created, what it will return. Let's try to see, okay? Maybe it will not return a good result. You, what a string had. Maybe we named it my string. Okay, next. Okay, I'll try to see. Okay. Yeah, it did return pretty good result. I would say it's not too bad, not bad. Okay, so that's the technical for recognizing the entities from this. Okay, there are a lot of options. Location GPEs, you can match the labels to these types. And the next thing we want to touch is called you often hear called sentiment analysis. What we want to do is to summarize if the message is positive or negative, or if it's subject or based on fact, objective, right? So what it does is actually the technique behind this it is very easy. It has a lot of it has a database behind this algorithm. It has a database. So if you show those kinds of words, love, great, and then if you the polarity score was it will add the polarity score 1, 2, okay, 0.5, okay. And with the text, so for the entire text, it adds up the polarity score. That makes sense. So let's try to see, okay? I try these, let's see. I believe we need to install this. It gives you a polarity score 0.5. It's actually positive. Negative is below 0, and goes from a -1 to positive 1. So let's try something else to see how it scores. I no love. Yeah, it goes to negative. I hate, then you will see it will go also definitely a lower score. And if I say I love and it's great, I would expect it to go up, right? It was 0.5 and I added 2 positive words, so I would expect to go, say, it did increase. It was 0.5, now it's 0.65. So that's basically how it works. Okay, if I write love, it still contests 0.5. It doesn't go, it doesn't double, okay, it doesn't add up. So what that means is it gets the average. It doesn't sum up, it gets the average. So it keeps between -1 and 1. That makes sense. Maybe we can see how it works. What else we want to try? For example, if it's a hate, then it goes here 0.15. So that's which is correct because hate give us negative 0.8 and love give us 0.5. So this hate and love gives us negative 0.15. Does that make sense? Remember, if I do hate, it gives us a negative 8. And if I do love, it gives us it gives us -0.8, and this one gives us positive 0.5. So this one has two words together. It gives returns the average of these two score. So that's basically how it works. It adds up all these words that have negative or positive feelings, and then gets the average. And same with the subjectivity. So these words, if it's subjective, then it will give you a subjective score, and then adds up, gets the average score. That's a score for you, the whole text, for the entire text. Okay. All right. So that's how it works behind this algorithm, and there could be some words that we use, but not in that database. Then likely it won't recognize. Give us an example. Do you think of any words that?
Other than love and hate?
Other
than love and hate?
Yeah. Some other words that maybe not frequently used, like it meant,
Dislike.
dislike. Let's see. Oh yeah, see, just like it again, 0. So it's basically just like probably not in the database. So the score is 0, which should be included, right? Okay. So that's how it works behind this algorithm, and then we can apply this sentiment, this score, to this tweets we got, and then get the score for this whole text. For example, we can see the score for each tweet he posted, right? Like use this the function, create this function. Basically, this function returns the sentiment score for each text. And now we apply this to that. By this function. And then we should get a score. So yeah, it returns a score for each entry on his post. See, some are neutral, some are looks most not that positive. See, some are neutral, some are negative score. Okay, and if you add the score, match the score with the dates, and then it can give you line plots to show which days he was very negative and which days he's very positive. Right? If you match the score to that date we have, then gives you a line plot that shows his polarity score of the post. Maybe this if it's very very negative, that could mean maybe the business is not that good, or some significant things happened. Okay, so you're very familiar with this, so I will leave this to you. I think this should solve all the problem with the assignments. Don't forget to use this to get the full text of the URL, and also I'll add a code to get the what's it called, domain name. Just that's the first part of the URL, so you can see the like frequencies of the website, mentioned website. All right. Any question for this lesson? Next week we are talking about how to save the prediction model you generated, you created, and then apply this model to new data. And also just change that prediction model into a website so customers can predict. Okay. So usually to the front people, you generate a website, and this website gets the prediction model from the back side, and then prompt a result to the customer. Yeah, so that's what we will cover at the next lesson.